All right, so this is the video where I'll go over the final five. I don't know if I'll be able to do all five of them in one video because they're each one of these problems could have its own video, honestly. I tried to write myself some notes so that I could kind of do them as quickly as possible. I think the one that I might struggle with a little bit is number 24 because there's kind of a lot of algebra for that one. These are all pretty tough questions, actually very, very tough questions. So each one of them took me quite a while to solve. So, and I'll be honest with you, for some of them, I kind of had to use some technology to help me figure it out because I couldn't figure out exactly what they wanted you to do to solve it. So, but anyway, let's try to get through as many as we can. Let A, B, C, D, E be a equilateral hexagon, equiangular hexagon. The lines A, B, C, D, E, F determine a triangle with area 192 root 3. The lines B, C, D, E, and F, A determine a triangle with area 324 root 3. If the perimeter of hexagon A, B, C, D, F can be expressed as M plus N root P, where M and N P are positive integers and P is not divisible by the square of any prime, what is M plus N plus P? All right, so I start by drawing a hexagon. It doesn't need to look like this, and it probably doesn't look like this, but it's just the easiest to draw. I'm not going to try to draw a complicated pentagon, right? Hexagon. So at first, when I read this, I didn't understand what it meant. When it says lines A, B, C, D, and E, F determine a triangle with area 192 root 3, I didn't quite understand what they meant by that. But then I kind of realized that what they mean is if you take these lines and extend them out, you create an equilateral triangle with an area of 192 root 3. So the area of that triangle would be 192 root 3, the red one, right? So I'll kind of write that over here. Now, if I create the equilateral triangle like this, the orange one, right? Yes, that equilateral triangle would have area 324 root 3, right? And the question wants to know what is the perimeter of the hexagon. So what I did was I kind of labeled each side with a letter. So I called this A, B, C, D, E, and F. And no, we do not need to solve for each one, right? We're not going to solve for each individual side. Now, let's think about it. One thing you should know is that when you have an equilateral triangle, which we know we have because each of these angles is 120, right? In a hexagon, all the angles have to be 120, which means that this angle has to be 60, and this angle has to be 60, and this angle has to be 60, and this angle has to be, right? So we know that these are equilateral triangles, right? And one thing we can do is we can figure out, there is an expression for the area of an equilateral triangle, which is that if each side has a length of, let's say, M, right? Let's just call it M, right? Then the area of that triangle is going to be M squared root 3 over 4. And I won't prove that right now, or else because the video is going to be long enough as it is. But I encourage you to look up somewhere on YouTube that the area of an equilateral triangle is M squared root 3 over 4, right? So if I decide to call the length of a side of the red triangle, let's call it K, right? Again, just to give it some kind of a name, then I can say that the area of the red triangle, right, would be K squared root 3 over 4 equals 192 root 3, where K would be the length of one of these red sides, right? So K squared would equal, so notice how the square root 3's would cancel out on both sides, right? The square root 3's will cancel out. And sorry, I'm just plugging in my laptop. So the square root 3's will cancel out on both sides, and then you'll multiply by 4. So you'll have K squared equals 4 times 192, right? Or K equals 2 root 192. And then by using similar logic, I could do the same thing for the orange triangle. I can say M squared root 3 over 4 equals 324 root 3, or M squared equals 4 times 324 or m equals 2 root 324. Okay, so now we have expressions for the lengths of the sides of the orange and red triangles, but what the heck do we do with that? Well, let's think about it. The perimeter of the hexagon would be A plus B plus C plus D plus E plus F, right? And we know that, for example, this side equals this side equals this side, and this side, because each of these is an equilateral triangle. So basically, if we take, for example, for K, right, we can say that 3K, which would be, we can say that 3K, which would be the perimeter of the red triangle, right, minus, now, again, notice how if this line is B, this is B, this is B. So we'd want to subtract 2B, right? But we'd also want to subtract 2D, right? And we'd also want to subtract 2F. So if we did 3K minus 2 times B plus D plus F, right? That would equal the remaining sides of the hexagon, which would be A plus C plus E, right? And then again, by similar logic, 3m minus 2 times A plus C plus E, right, will equal B plus D plus F. So now you're probably thinking to yourself, where the heck do we go from here? So let me delete this because I need more room. So now what I can do is I can say, well, notice how if I added these two equations together, right? Notice how, like, if I do 2 times B plus D plus F plus 2 times A plus C plus E, that gives me 2 times the perimeter of the hexagon. So if I kind of add these equations together, I'll have 3K plus 3M, right? 3K plus 3M minus 2 times B plus D plus F plus A plus C plus E, which is the perimeter, 2P, right? Equals A plus B plus C plus D plus E plus F, the perimeter. So I have 3K plus 3M minus 2P equals P, or 3 times K plus M equals 3P, or P equals K plus M. So the perimeter of the hexagon is equal to the one side of the red triangle plus one side of the orange triangle, which we calculated, right? We said K was what? K was 2 root 192, and that's okay, P plus, and then M was 2 root 324. And if you simplify this as much as possible, you end up getting 36 plus 16 root 3. And the question wants M plus N plus P, 36 plus 16 plus 3. And that adds up to 55, choice C. So the answer to 21 is choice C, 55. Okay, it's pretty tough, but it only gets worse. So just letting you know. I'm trying to go fast so the video is not an hour long. This one drove me nuts, and I'm going to be honest with you, this one I had to use technology to help me because I don't know how to solve it without it. I'll kind of show you what I did up until using the technology, though. So it says Hiram's algebra notes are 50 pages long and are printed on 25 sheets of paper. The first sheet contains pages 1 and 2, the second sheet pages 3 and 4, and so on. One day he leaves his notes on the table before leaving for lunch, and his roommate decides to borrow some pages from the middle of the notes. When Hiram comes back, he discovers that his roommate has taken a consecutive set of sheets from the notes and that the average mean of the page numbers on all remaining sheets is exactly 19. How many sheets were borrowed? So basically the idea is he has 50 sheets of paper, right, back to back with 1 and 2, and then the next one's 3 and 4. Third one is 5 and 6, et cetera, right? But some of the pages from the middle get taken out. And what he notices that the average of the remaining page numbers is 19. So the question is, how many pages were borrowed? So basically what we know is, like, let's say that, so we know we have 50 pages, right? And let's say after page M, now, obviously he has to start stealing from an odd number. So I'm going to come up with 2 variables, M and N, right? Where 1 is going to be less than M is going to be less than N is going to be less than 50. right? And M is going to be the last page before the stolen page starts, and N will be the last stolen page, right? So M is the last remaining page before the set of stolen pages, and N will be the highest page number that's been stolen, right? This is one less than, right? So now, what is that? Now we need to find the average, right, of the remaining pages. Well, the first M pages are there, or first M page numbers are there. So we can start by summing up 1 to M, which would be M plus 1 divided by 2, right? Now, how do we add up the pages after N? Well, if you think about it, the sum of the pages after N would be the sum of the first 50 pages minus the first N pages, right? And that would give you the sum of the remaining pages after N. So that would be plus the sum up to 50, which would be 50 times 51 divided by 2 minus N. Oh, that's not a good N. Oh my God. N plus 1 over 2, right? Now, how many pages are total? Because remember, we want an average. M plus 50 minus N, and that has to equal 19, right? So this is what we want to solve, but the problem is we have two different variables, right? So what I'm just going to do is, instead of showing every single piece of algebra and trying not to make the video too long, I'm just going to kind of show you what my end result is here. And hopefully you can also get that same result. Actually, here, I'm going to do something. I'm going to see if I can copy and then see if I can switch to a different thing. I don't know if this will work. No, I guess it doesn't. So here, again, I'm just going to write it one more time, and then you can see. So it's M plus 1 over 2 plus 50 times 51 over 2 minus N plus 1 over 2 all over M plus 50 minus N equals 19, which if you simplify, put everything together, complete the square, and kind of combine it into one nice thing, you should get this. N minus 37 over 2 squared minus M minus 37 over 2 squared equals 650. Now, by looking at this, you might not know what type of graph this would have if we treated N as X and M as Y. It actually creates what's called a hyperbola. It creates a shape that looks like this. So if you haven't studied conic sections, you're probably not going to have any idea what that would look like. But that's actually a hyperbola. The center being 37 over 2, comma 37 over 2. And the distance from the center being the square root of 650. Right? Now, here's the thing. We need to find an ordered pair. Basically, we need to find what's called a lattice point, which means a point that's on this curve where both the X and the Y are both integers. And the truth is, I don't know how to do that without using technology, right? So the only way that I was able to solve this was by using technology, right? And what I did was trying to find this. I plugged it into a program called Desmos, right? Which I know you're not really supposed to do this during AMC, but I know many of you probably used a computer anyway. I mean, you were on a computer anyway, so. So if I'm going to share my screen in just a second. I'm just going to type it in. My computer's being really slow. I just want to show you exactly what I did. Come on, it's being very slow. Horrifically slow. So come on. I don't know. It's really slowed down quite a bit. Okay, so here, what I did was I did X minus 37 over 2 squared minus Y minus 37 over 2 squared equals 650, right? And then I had to zoom out quite a bit to be able to see it, right? And then what I did was I kind of looked until I found a point that was both integers, right? And it turns out that 4419 is on this curve. So, right, you can see here 4419. So that means M is 44 and N is 19, or N is 44 and M is 19, right? So going back to here, right? So going back to here, so what does that mean? Well, it means he started stealing from the 19th page. So he stole pages 20 up to page 44, right? He stole from 20 to 44. Well, technically 20 to 43, right? So how many pages did he steal? Well, 44 minus 20 is 14, is 24, sorry. I think there's a mistake. It was supposed to be 44 and 18. And basically, so it's 44 and 18, which if you divide that by 2, right? 44 minus 18 is 26. And then since it's 26, but it's back and back, it would be divided by 2 gives you 13. So the answer should be B, 13. Even if you got the answer as being 12 by doing 44 minus 19, then you would still know that it would have to add up, it's, the closest answer is 13. So 13 has to be the right answer, right? Okay, so the answer for number 22 is B, 13. Okay? I'd be very curious to see if anybody found a better way to do that question, because I couldn't think of anything better. I think I might just do 23 and then do a separate video for 24 and 25, because each of those could use their own video. So this one is this one's a long, wordy one, but it's actually not that bad in terms of the math. It's like you just have to kind of think about all the possible things that can happen. So Frida the frog begins a sequence of hops on a 3x3 grid of squares, moving 1 square on each hop, choosing at random the direction of each hop, up, down, left, or right. She does not hop diagonally. When the direction of a hop would take Frida off the grid, she wraps around and jumps to the opposite edge. For example, if Frida begins in the center square, makes 2 hops up, the first hop would place her in the top row, middle square. Second hop would cause Frida to jump to the opposite edge, landing in the bottom row, middle square. Suppose Frida starts from the center square, makes at most 4 hops at random, stops hopping if she lands on a corner square. What is the probability she reaches a corner square on one of the 4 hops? Okay, blah, 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 blah. A lot of words, a lot of words. Let me just explain what it's saying. It's saying that, say you have a 3x3 grid, right? You have a 3x3 grid, right? And you have a frog that starts in the middle square. I can't draw a frog. I'm just going to draw a little face, right? Little hippity hop face. Now this frog at every turn can go either up, down, left, or right, randomly, right? And we want to know the probability that the frog will land on one of the 4 corner squares within 4 hops. Now, one thing that you have to keep in mind is that if the frog lands here at the bottom middle, they can then jump up to the top middle. So it's like they can go sort of off the board and jump to the opposite side. But the frog can never jump diagonally. So it cannot do that. That does not allow. That's not allowed. Okay. So let's think about all the things that could happen. Like basically we want to just break this down into cases, right? So first thing you want to note is that no matter what in the first turn, the frog is either going to go here, here, or here, or here. And from any one of those spots, his chance is the same. So we don't have to worry about which of those 4 he goes to, right? Or she, it's Frida, right? But now from any one of those positions, the frog has a 2 out of 4 chance to go to one of the corners from any of those spots, right? If it's from here, he can either go left, she can go left or right. If it's here, she can go down or up. If it's here, she can go left or right, here, up or down. So she has a 2 out of 4 or 1/2 chance of basically going like down left, down right, right down, right up, like of going sort of like in an L shape to get to a corner sort of within 2 hops, right? Does that make sense? So she has a 1 out of 2 chance to do that, right? Now, I'm trying to just erase. Whoops, I erased too much. What's another situation that she could do? Um, she could go. So there's also the probability that she could hop down one or she can hop to any one down, up, middle, and then hop back to the middle, right? So she can go down, up, or up, down, or left, right, or right, left, right? She's back in the middle. At which point now she is back in the middle and has that same half chance of ending up at a corner that we talked about in step one, right? Because she's back at the middle. So from any one of those edge spots, middle edge spots, right? She has a 1/4 chance to go back to the middle, at which point she has another half chance of getting to a corner again, because that can be done within 3 hops. Because she can go like down, up, uh, down, up, down, right, or down, left, or she can go down, up, down, right, or she can go down, she can go down, up, right, up, or right. So that's a 1/2 chance that she does that in exactly 4 hops, right? What's another thing that could happen? She could go off the board, right? So she could go down and then go down, which would take her around the whole board, right? And now she's here, at which point she now has a 1 out of 2, 2 out of 4 chance, or 1/2 chance to go either left or right. So given the 1/4 chance that she hops off the board to the other edge, and again, any of these can happen no matter which of the 4 middle spots she goes to, right? So then she's at a 1/2 chance to then go to a corner, right? Now, there's one other possibility that could happen, right? The other possibility that could happen is that she goes, trying to erase here, trying to erase here, trying to erase here. The other possibility is that she goes, like, let's say she goes down, off the board, back, and then can go either left or right. So what's the probability of that happening? Well, it's the 1/4 chance she goes off the board times a 1/4 chance that she goes back the other way, and then 2 out of 4 ways to go either left or right, or if she's here, down or up, or she's here, left or right. So 2 out of 4, or 1/2 chance that she goes to a corner. And it turns out that these are the only possibilities, right? You might think to yourself, well, no, there's got to be other things that can happen. You can try to figure other things, but there's really no other possibilities. One other thing I thought of was, what if she goes down, up, up, down, but then she's stuck? That's 4 moves, right? Or what if she goes down, up, up, or what if she goes down, up, then again she's stuck. So anything that gets her in the middle, she's done, and she can't. There's no way for her to get to a corner because she can't go diagonally, right? So those are her only possible things. So if you add these up, you get 1/2 plus 1/8 plus 1/8 plus 1/16, and adding those up gives you 13 out of 16. 13 out of 16, which is, let me go back. That is choice E. So the answer is E. Sorry, I'm trying to write that. The answer is E. 13 out of 16. Okay? All right, I think I'm going to end the video for this one because I think it's probably already too long, and then I'll do my last video, 24 and 25. 24 is kind of annoying. 25 is actually not as bad as you would think. Like 23 and 25 seem terrible, but if you just kind of count out the cases, it's actually not that bad. There's not as many things to consider. The harder thing is to make sure you've covered every possibility and you haven't double counted anything. So you have to be anytime you have these like counting problems, you have to be very systematic. That's the most important thing. All right. Okay, like I said, if you have any better ways to solve any of these, please let me know. All right. I won't be upset if you tell me that you have a better way to solve it. Okay, so, all right, I'm going to end it now. Bye.